So we're going to talk about how to calculate the mass percent composition of a compound, or you'll also see it phrased as the percent composition by mass. So the whole point of this is we're looking at the mass of a part over the mass of a whole. So a percent is always part divided by the whole. In this case, we're looking at the mass of a certain component of a compound divided by the mass of the whole compound. So there are three general steps to follow when you calculate percent composition by mass. The first thing that you need to do is you need to calculate the molar mass of the compound. So step one is to calculate molar mass of the compound. So that'll be the mass of the whole thing. The second step is to figure out the mass of the different pieces. So we're going to calculate the mass of each type of atom. And you do this using the molar mass of that particular substance. So say a compound has 8 carbons in it. We would take 8 carbons times the molar mass for carbon, which is 12.011 grams. And so we do 8 times 12, and that would give us the mass of the total carbon in that compound. So after we calculate the mass of each type of atom, we just need to divide. So we need to divide the mass of each type by the molar mass. And then multiply by 100. That gets it into the percent form. So we're basically going to take what we get in number 2, so the mass of all of our pieces, divided by the mass of the whole, times 100. So let's do a couple of examples. Our first example is C6H12O6. So we have 3 different elements in this compound, all in different quantities. And we want to determine the mass percent composition of each of the components. So we're going to end up with 3 different percentages. So the first thing that we need to do, though, is calculate the mass percent, or calculate the molar mass. So my molar mass I have 6 carbons, and so my carbons are 12.011. And then I'm going to add my 12 hydrogens, and hydrogens are 1.0079 grams per mole. And then I'm going to add my 6 oxygens, and oxygens are 15.999 grams per mole. Almost ran out of space. Okay, so let's figure out what that is. There we go. And I get my molar mass to be equal to 180.15 grams per mole. So that's the total mass of the whole compound. So for each of these, we need to figure out the mass of each individual component. So for carbon, I have 6 carbons. The mass of carbon is 12.011. Hydrogen, well, here, let's just do carbon first. So 6 times 12.011 gets me 72.066 grams per mole. Now, if I want to find my percent composition of carbon, I'm going to do my carbon part divided by my whole. So I'll do 72.066 grams per mole divided by 180.15 grams per mole. times 100. You can't forget that part because that'll get it into the percent. So in this compound, carbon makes up 40% of the mass. So carbon makes up 40% of the mass. Okay, so let's do hydrogen. And I have 12 hydrogens. Mass of hydrogen is 1.0079 grams per mole. Gets me 12.09 grams per mole. If I do 12.09 divided by 180.15, so that's my part divided by my whole, and then times 100. Gets me 6.7%. So 6.7% of the mass is due to hydrogen. So then the remaining mass should be due to oxygen. So let's just check. Let's go ahead and calculate oxygen the long way. I have 6 oxygens. Each oxygen is 15.999. Gets me 95.994. So my part divided by my whole, 95.994 divided by 180.15 times 100 gets me 53.3%. So 53.3% of the mass is oxygen, 6.7% of the mass is hydrogen, and 40% of the mass is carbon. So those should all add up to 100% because nothing else is in this compound. So if I do 40 plus 6.7 plus 53.3, I get exactly 100%, which is what I should get. Now, I could have, instead of calculating oxygen the long way, I could have just added these up and then subtracted from 100 because I knew that the remaining percent should be oxygen. Let's look at another example. So this example, example 2, is H3PO4. So step 1 is to calculate the molar mass. So I have 3 hydrogens. I have 1 phosphorus. Phosphorus has a mass on my periodic table of 30.974 grams per mole. And then I have 4 oxygens. Okay, so 3 times 1.0079 plus 1 times 30.974 plus 4 times 15.999. Gets me a molar mass of 97.9937 grams per mole. So essentially 98 grams. So 97.99. I'm going to go ahead and round those last 2 numbers off just to make it easier. So 97.99 grams per mole. So if I want to find the percent composition of each of these components, we're going to find the mass of each part and then divide it by the whole. So this is our whole. And so we're going to start with finding our hydrogens. So I have 3 hydrogens, each with a mass of 1.0079. So 3.02 grams per mole. Divide that by my whole, so 3.02 divided by 97.99 times 100. So 3.1% of the mass is due to hydrogen. So 3.1% of my 97.99 grams is hydrogen. Okay, so let's do phosphorus. So I only have one phosphorus, and it had a mass of 30.974. So it's the same thing, 30.974 grams per mole. So if I take that mass of my part divided by my whole, notice the whole is the same every time because we're still using the mass of the whole thing, and that's going to be the same regardless of what component you're looking at. So 30.974 divided by 97.99 times 100 gets me 31.6% phosphorus. So in this compound, if I have 1 mole of it, 31.6% is going to be due to phosphorus. So then the remainder is going to be oxygen, and I'm going to show you this the other way now. So I know that I have to have a total of 100%. I've already used up 3.1% and 31.6%. So whatever's left has to be due to oxygen. So if I do 100, because 100 is the total, 3.1 plus 31.6 gets me 34.7. So if I do 100 minus 34.7, gets me 65.3%. So 65.3% of this compound is due to oxygen in terms of mass. So this compound is 3.1% hydrogen by mass, 31.6% phosphorus by mass, and 65.3% oxygen by mass. So let's actually use mass percent in a different way. Let's look at one more example. So example 3 says you have 60 grams of toluene. Toluene has a formula of C7H8. And the question asks, what is the mass of the carbon? So if you have 60 grams of this stuff, how much carbon do you have? What's going to be the mass of the carbon? So the first thing we have to do is we have to figure out the percent carbon in the compound, because the percent carbon is going to be the same no matter whether we have a mole, half a mole, doesn't matter what mass we have. As long the percent carbon will always stay the same. So the first thing we have to do is figure out the molar mass of toluene. So we have 7 carbons. Carbon has a mass of 12.011. And we have 8 hydrogens. Calculate this really quick. It gives me a molar mass of 92.14 grams per mole. Okay, so the only thing I care about is the carbon, so we're just going to focus on that one. So the mass percent of carbon, the mass just from the carbon would be 7 times 12.011. So 7 times 12.011 gets me 84.077. My total mass is 92.14, so let's do my part divided by my whole. And then times 100. So it's 91.2% carbon. So 91.2% is going to be carbon whether I have 60 grams, whether I have 100 grams, whether I have 200 grams, no matter what. It's always going to be 91.2% carbon. So I can use this percentage to figure out just the mass of the carbon out of my 60 grams of the toluene compound. So I'm going to undo this. I'm going to convert it back from a percent to a decimal. So I'm going to do 91.2% divided by 100, which will get me 0.912. That's just taking it from a percentage back to a decimal. And then I'm going to take that percentage as a decimal, so 0.912, times my total mass, so 60 grams, to figure out the mass of just the carbon. And so when I do 0.912 times 60, so after I do 0.912 times 60 grams, I get 54.72 grams of carbon. That means in my 60 total grams of toluene, 54.72 grams of that substance is due to carbon. The rest would be due to hydrogen. So hydrogen tends to make up a very small amount in terms of mass, whereas we might have many atoms of hydrogen. Each atom of hydrogen has such a small mass. Hydrogen tends to make up a smaller percent mass of the total compound. Elements like carbon, oxygen, phosphorus, those you're going to see a much bigger percent composition.